Welcome to the online ACR video training. This training explains homing on the ACR9000 series controllers, including the different settings for homing and also homing to the reference mark. Let's get started. ACR homing uses the jog feature, allowing homing of multiple axes simultaneously. The primary commands are jog home with the axis name and either 1 for positive direction or -1 for the opposite direction. Jog ACC sets the acceleration ramp and jog DEC the decel ramp. Jog vel sets the homing velocity, and these are all in user units based on the scaling you set in the configuration wizard. Let's take a look at how to configure your EPL demo for homing. Okay, so I've gone through the configuration wizard with the 9040 training and set up my x-axis and y-axis attached to master 0. Now if I go into the configuration wizard, you'll notice that under the default I had my hardware limit switches disabled. So if I take a look at that, what I'm going to do, if I take a look at my EPL demo, all my inputs are actually wired into my x-axis. So I'm going to assign my positive limit switch on the x-axis as the very first input 0. And when I do that, you'll notice that in the configuration wizard, the negative limit switch is already assigned as the second push button on my demo, and the home limit is input number 2. By default, these are set as normally closed. Typically in machine installations with end-of-travel sensors, you'll want these normally closed. In case the cable or the sensor fails, it'll fail open and it'll prevent motion. But for our demo, we'll set these limits to normally open because our push buttons are momentary contacts. Be sure to enable the actual limit sensors up above as well too, and you'll notice that the hardware limit decel defaults as 500, and that's in terms of user units. So we're all set here, and then we'll do the same on the y-axis. Go into the fault, enable. Now this is a little bit different. Instead of my limit switches going on my y-axis, I'm actually going to change this over to the x-axis unit, and then use, since my momentary push button contacts are all wired into that unit itself, I'm going to say 3, 4, and 5, or my positive limit for my y-axis, and these are also going to be normally open as well too. So I'm going to click next. And go through and finish and download. After downloading, we're ready to start an easy homing program. Here's a simple little program where we're going to home both the x-axis and the y-axis at the same time. We'll set the velocity for 5 for the x-axis, 2 for the y-axis, the acceleration in 1/10 of a second. So in terms of inches per second squared, 50 for the x and the y to 20, and then the decel will also be set the same. I'm going to home the x-axis in the positive direction and the y-axis in the negative direction. Let's take a look at what this looks like in ACR-View. Alright, so I've finished downloading, and I'm just going to go into the program editor, prog0. You'll notice that the program is at the very beginning. That's the first command that defines the beginning of the program. N-P defines the end of the program. And then I'm just going to say jog vel x5 y2 x50 y20. Same thing for the decel. Home. I'm going to home x in the positive, y in the negative. I'm going to put a comment over here. I'm going to tab over. Be sure when you tab over, go ahead and put a space, colon, space, rem, home, x positive, y negative. I'm going to download. You'll notice that it's only going to download prog 0. Short little program, shouldn't take that long. Go ahead and download. Press OK. Then if you take a look at the common status panel, this gives the actual and the commanded positions for the axis 0 and axis 1. You'll notice my drives are faulted but not enabled, so I need to go in the terminal emulator and need to enable my EPL on. And then on the controller I've got a solid EPL light. Same thing with Aries leftmost LEDs are now solid, which means my drives are now communicating the Ethernet Powerlink to the controller. And then if I do a drive on XY, my rightmost LED on the Aries PEs are now solid green, and I do have holding torque on the motors. I'm going to hide my buttons and shorten this up so I can see the common status panel at the same time. Then I'm just going to run prog 0. You'll notice the motors are turning in the opposite direction. The jogs are active, and you can see the actual and the commanded positions incrementing in the common status panel. So I'm just going to push the third button, which is input number 2 on my x-axis, will then stop, and then the sixth button, which is input number 5, and my y-axis will then stop. You'll notice both the actual and commanded positions are then reset to 0, and then the home found bit is set active on the screen as well. Okay, so you've homed the motors, but where exactly is home? Is it anywhere in the active region of the home sensor? Based on the commanded jog velocity and the deceleration and friction within the system, this will vary. For higher accuracy, if we commanded a slower velocity, it'll be more repeatable. But if we have a very long actuator, we don't want the operator waiting on a slow homing process, wasting time when we really want to be making parts. So we can back up to the edge of the home sensor at a slower speed after doing a high-speed homing to the home sensor. This will decrease the variance of our home position and thus also our batch-to-batch part variation. To account for any hysteresis in the mechanics and hold the home position to the unidirectional repeatability instead of the larger bidirectional repeatability, we can define that we'll approach the edge of the sensor either in the positive or the negative direction. So this is what X and Y look like. X-axis ran positive until the home sensor was found, but we didn't enable backing up to the home sensor. Same thing with the Y-axis, which is figure B. It was going in the negative direction and then stopped after the home sensor was found. Let's expand our simple program. We'll add jog home VF, which is the final velocity of the homing, for backing up to the edge of the sensor. We'll enable backing up to the edge of the home sensors with set 16152 and 16184. We'll home to the positive edge in the positive direction with 16153 and 154 clear, and then for the y-axis 16185 and 16186. So let's try this. Okay, so I'm going to go back into the program editor, into prog 0, and then before the jog home, I'm going to add the jog home BF x1 y.2. I'm going to do set 16152 and set 16184. I'm going to add a remark. This is enable backup to home you'll notice that the x and the y axes between axis 0 and axis 1, it's you just add 32 between the bit numbers, and then you get the next axis. Then I'm going to set the positive edge, and the final direction will also be positive. These bits by default should automatically be clear, but in case they ever get changed, it's always good practice to reset them in your homing subroutine. And again, comments don't cost you anything. Makes the code more legible. Go ahead and download. So if I go ahead and start running the program, my axes are spinning. You'll notice on the x-axis, if you push and hold input number 2, it keeps going, looking for the positive edge. After you release the input number 2, it'll reverse, finding the positive edge of the sensor, which is you pushing the button a second time, it'll reverse, looking for the positive edge in the positive direction, so when you release it, it'll stop and homing is done. It gets reset to 0. The y-axis, if you just push and hold input number 5 in, it'll stop, reversing, looking for the positive edge of the sensor, and it'll stop when you release the button. Let's consider the x-axis. A positive home move is started with the jog home x1 command at the jog ACC and jog jerk values. The jog velocity is reached, and the move continues at that velocity until the home input goes active. And our sample jog velocity is x5. The negative edge of the home input is ignored, and the move continues until the positive edge is detected. At this time, the move is decelerated at the jog TEC and jog jerk command values. For our x, since it's moving in the positive direction, the rising edge is the negative side, so it'll wait until it sees the falling edge before decelerating. After stopping, the direction is reversed in a second move with a peak velocity specified by the jog home VF value is started. In our sample, jog home VF is x1. This move continues until the positive edge of the home input is reached. The x-axis, though, is moving in the negative direction when it finds the edge, and thus reverses, going in the positive direction until the button is released a second time. The reversed move on the x-axis is another move at the jog home VF velocity. As soon as the home input positive edge is reached, the move is immediately terminated, the load is at home, and the absolute position register is reset to 0. If you wanted to reset this as something other than 0, use the reset command such as res x10. For our y, since it's homing in the negative direction, it'll first encounter the positive side of the switch, so it'll immediately decelerate and the positive edge is found, and then reverses, moving in the positive direction, and stops after the input is released. In our example, if we wanted the x-axis to immediately stop after reversing off the sensor, set the negative direction as the final direction, using set 16154. Many machine operators expect during the homing that it'd stop after creeping in to find the home sensor instead of reversing a second time to approach it in the correct final direction, so choose your settings carefully. Also, if an end-of-travel sensor is activated before the home sensor during homing, meaning the home sensor was behind the starting position, the controller will reverse direction. This will not fault the controller and will effectively bounce off the end of travel, now searching for the home the other direction. To view the axis home and end of travel limit status, on the left hand side, go down to the status panels under bit status. Under the bit status, go to axis flags and then go down to the quinary axis flags. This is for axis 0, which is our x-axis. There you have the limit status, 16128 for the positive end of travel, 16129 for the negative, 16130 is the home sensor. Once the home sensor is found during homing, 16134 is set, but only until a new move is commanded. If a home sensor isn't found, 16135 will be set. You also have the polarity of the home and end of travel limit sensors, 16144, 16145, which for normally closed would typically be green, and 16146, which would be red for a normally open home sensor. If end of travel limit checking is turned on, that's 16148 and 16149. 16152 tells you if homing backup is enabled, and then also 16153 tells you whether or not it's homing to the negative edge of the sensor or the positive edge of the sensor, and 16154 sets the final direction. Then if you go to axis 1, that will be for the y-axis. So in the Configuration Wizard's fault screen, this is where you enable the limit switch checking and then also assign the specific limit switches and the home sensors and their polarity. Optionally, there's also the software limit switches that can be used as well too. What is this actually doing? It's using the hlim command to enable the limit checking, hl bit to assign the limit for the positive limit, and then automatically the next two inputs are the minus end of travel and the home sensor. hl dec is the hardware limit deceleration rate. The default value is 0, but the Configuration Wizard default value is 500. So you can actually change these in the program if you wanted to. What happens when you hit a hardware limit switch or a software limit? On that specific axis, it would set the kill all moves on, say, your x-axis would be bit 522. This would prevent motion on both the x and the y-axis. In addition, it also sets the kill all motion request bit 8467 on axis 0, so those bits would need to be cleared. But as soon as you clear those bits, then you can reverse direction. Z-channel homing can be done in Acrobasic language using the MC command. Specify the axis, then the incremental distance and the mode. This is a hardware capture similar to IntCap. Typically, the incremental move should be large enough to guarantee a complete revolution. At least 1.5 revolutions are suggested. Mode 0 is rising edge of the Z-pulse on encoder. It uses the master's coordinated motion trajectory values for accel, stop, and velocity. Capture latency is less than 400 nanoseconds for the ACR9000. For hardware interrupt captures with the onboard inputs, latency is less than 1 microsecond due to the opto-isolation. A marker seek operation is as follows. 1. Start the incremental move, start looking for the marker. 2. When the marker is located, decelerate to a stop. 3. Reverse direction and move back to where the marker was located, and then reset the encoder position to 0 and terminate the MSeq mode. A master can only control one MSeq at a time. If multiple axes are indicated, they will execute in the order that they appear. If the incremental move ends without the marker being located, the corresponding capture complete flag will not be set and the encoder position is not reset to 0. So let's add this to our program. Okay, so I'm back into program 0 in my ACR-View, and I'm just going to, after the jog home x1 line, add a couple more lines. Now, the jog homing will not pause the program execution, so I need to force it by doing an inhibit, which will pause program execution, and 16134 is just going to wait until the x-axis is done on the homing routine. Same thing on the y-home. And then I'm going to set my accel. I can set these commands separated by a colon all in the same line. Makes it a little bit easier. And then I'm going to do my mseek on my x-axis. And then I can copy and paste for my y. And if those are done, which is 777 and 809, then print to the terminal window, homing successful. Little message to ourselves there. Let's go ahead and download. Click over on the terminal window. I'll run. Starts the homing. Hit the home sensors on both axes, and then after that's done, then you can see the x-axis moves to the z as well as the y-axis, and then you can see that the homing is successful. Congratulations on writing your own homing program with Z-marker capture. The homing example in the online help homing section and programmer's guide is very similar. It uses user bits 128 and 129 and sets these if the X and Y homing are successful. You'll note that after the jog home, instead of inhibiting like we did for simplicity, it loops while the homing is executing. This is a better way to program, and if after a certain amount of time, if either axis weren't successful, you could jump to an error program or send a message to your HMI for the operator that the homing is timed out. This completes the ACR homing training. Key points to remember are that multi-axis homing can be executed simultaneously. Backup to home finds the edge of the home sensor. Be careful selecting the final direction. Finally, mseek provides high accuracy